Good evening and welcome to our lecture on collection systems. You see that I'm beginning with the same structure that we always start with, and now we're over to the right-hand side of the top part of this structure, and we're dealing with how fast can we collect money once somebody has mailed it. And our major topics tonight are understanding the various options firms have to collect payments, to differentiate among them and choose the best one, and understand the data that's needed in order to make those decisions. And also we're going to talk a little bit about lockboxes. Within this section that's highlighted in yellow called collection float are three subsections. Mailing time, how long it takes us to deal with the check once it's received, and then once we've deposited it, how long will it take until the funds are available to us. And we'll start with this concept of dollar-day float, which allows us to calculate the cost of waiting for our money. We will calculate the average dollar-day float, the average collection float, and the annual cost of that float. And the term float means we're waiting. Now here is all the same data that was on that PowerPoint slide. This is page 323 in the text. And the calculations that I mentioned from that slide are shown here. In the top section, we have 4 remittances. The first one takes 2 days to collect, the second one takes 5 days to collect, the third one takes 7 days to collect, and the fourth one takes 10 days to collect. And we're simply multiplying across the left hand from the left hand to the right hand side to come up with a total dollar-day float. For example, 50,000 times 2 equals 100,000. We do that for each of the lines and then sum them to come up with a total dollar-day float of $9,610,000. Our next step is to calculate the average dollar-day float, which is simply dividing that total dollar-day float of 9.6 million and change by 30 days in the month to come up with the average per day. And you see that dividing 30 into 9.61 million produces an average dollar-day float of $320,333.33. To find the average collection float, we take the total dollar-day float of 9.61 million and divide it by the sum of the remittances, 1.751 million, and we see that our average collection time is 5.49 days. And finally, using the average dollar-day float and applying our relevant cost of funds to that, in this case 8% in this example, we can come up with the annual cost of that float. So taking the average dollar-day float of $320,333.33 and multiplying that by 8%, the relevant rate of return in this example, we see that the annual cost of that float is $25,626.67. And we want to stop and think about the relative attributes of decentralized versus centralized collection systems. And what these terms mean is, do you have a lot of places where people mail checks to various locations that are closer to them? Or do you have all of the checks come to one centralized location, probably your headquarters? And in comparing the two, we need to think about these 3 components of our float: the mail float, the processing float, and the availability float. The 2 major advantages of a decentralized system are that the mail delay is minimal because customers are mailing things to someplace near where they are. And the availability delay is minimal because the deposit is being made in a bank near, most likely near the bank where the customer's check is drawn. Disadvantages to the decentralized system would be staff maybe not getting to it because they're out in the hinterlands dealing with other things, and so it may take some processing time that wouldn't take place in a centralized system. The big advantage to a centralized system, conversely, is that the processing time is quite quick because it's probably all automated with fancy machinery. But the mailing time will probably go up, and the availability time will probably also rise because of the distance of the centralized system from the customers. Next, we'll look at lockbox systems. And what this is the bank acting on your behalf to have sites wherever you choose them to do so, where customers can mail checks directly to a P.O. box generally, and then the bank will record those deposits and then inform you of it. These are called lock boxes. And the differentiation between a retail and a wholesale lockbox is that the retail handles huge volumes of small payments. For instance, maybe water bills or payments on credit cards for Macy's, something like that, where there's just tons of them coming in. A wholesale lockbox system is designed for fewer payments of larger amounts. But in all of these situations, whether it's a company processing center or a lockbox system, we need to deal with this equation that's down here at the bottom of this slide, and is also equation 9.1 on page 324 of your text. And I know you like me to commit these formulas to real words, and so that's what I'm going to show to you next. Okay, here it is in plain English, and basically what we've got is some variable cost and some fixed cost. And the variable cost relates to the amount of money and how long it takes to clear, and the opportunity cost of the funds. That's what's here in the parens. We've got three elements within this inside paren here. The remittance face value, how many days it's outstanding, and well, how many days float there is before it clears, and what is the relevant cost of funds. And then there's going to be a variable cost of dealing with it, just the cost of handling, plus a fixed cost. So we have variable cost plus fixed cost to equal the total cost. And well, by the way, I missed it. We're multiplying that variable cost times the number of remittances. So it's variable cost times number of items, and that variable cost consists of the opportunity cost of not having those funds plus a cost of remittance. And then add to that the fixed cost. And now I'm going to substitute some data into this formula using the data on page 325, which I'm showing on the lower portion of the screen now. And we're going to calculate the cost of a decentralized system. And so what we have is 1,000 remittances that goes here on the left, and we have a remittance face value of $1,500, and we'll slide that into the remittance face value slot. In a decentralized system, it's expected to take 7 days to clear, so we drop that in to the formula as well. And in this example, the relevant cost of funds is 10%, so we'll put that over here and divide it by 365 to get the daily opportunity cost of funds. And then there's a 25-cent charge for each remittance. We'll add that. That's our last component of the variable piece. And finally, a fixed cost of $100. And now you see I'm showing at the bottom of the screen the author's solution to this formula that I have shown you in my handwriting up above. And this totals up to be $3,227 total cost. And again, this is the sum of the variable and the fixed for the decentralized system. Now the author goes on page 325 and calculates also the cost of the centralized system using the same formula, and finds a cost of $3,266. It's slightly more for a centralized system for this situation. Now I want to move to page 327, where we're utilizing the very same formula and we're comparing two bank lockboxes as opposed to comparing a centralized and a decentralized system, but it's the same calculation. And that's probably most easily seen on this first line next to Citibank with 1,000 remittances with a face value of $1,500, 6 days to clear, a 10% relevant cost of funds, a 45-cent variable cost being charged per item, and $225 fixed cost. So that's the Citibank lockbox. And it's being compared to the Chase lockbox. And what we find is that the Citibank lockbox is more expensive for this set of remittances than the Chase. Now, to see how this fixed and variable cost can play into a decision, I've now put the next set of examples from the bottom of page 327 on the lower half of your screen. And what we did, moving from that first example to this lower example, was to increase the volume and decrease the remittance size. So now on the bottom we're looking at a high volume, low remittance, and studying the differences between Chase and Citibank. Citibank had a lower variable cost than Chase, and so in a high volume situation, this should help us see that Citibank is only 45 cents per item, while Chase is 50 cents per item. But Citibank takes another day to clear. So the days to clear is a little higher under Citibank, but once we go to 100,000 in volume, what we should expect to see is that Citibank becomes cheaper. And sure enough, back at the bottom half of your screen now, running through the calculations for Citibank, we see a lower cost of $47,695 compared to Chase, which was lower in the first example. Now it's higher at $52,000 and change. Moving on, we have a couple of other alternatives: pre-authorized payments and electronic corporate trade payments. We're all, most of us, pretty familiar with these pre-authorized payments in the States. Many companies want us to do that, where they can just hit our checking account. They can debit our checking account when they're ready, because they already have authority from us. For instance, a lot of people pay their electric bill or their cable bill or their water bill automatically. They set it up. There's a setup procedure that costs money, but once that setup is done, the recipient, the water company or the gas company or whoever it is, enjoys immediate availability upon invoicing, and the float time is gone. In a corporate environment, you have invoices being sent electronically, and then for large amounts an approval process. And I used to do this back in the day. We would get our invoices from our vendors, and we'd have an approval process that we went through, similar to an approval process for paper invoices. But that once it was approved, we actually logged on to our bank and made the payment directly, immediately. And this eliminated the float time for our vendor. Now the chapter continues on to look at various iterations of breaking down customer groups and remittances and mail times to try to find the optimal combination. Maybe we'll use several lockbox models, some for certain customers, others for different customers, to maximize our value, minimize the float time by subdividing these groups and putting them into lockbox situations that will minimize the float for their attributes. And you'll find that discussion beginning on page 330 of your text. Now, we aren't going to go to this level, but I do want you to skim this, take a look at it, and make sure you understand the concept that if we separate our customers into groups, we might be able to achieve even less collection float and therefore ultimately improve company value. And this concludes my substitute lecture that I did not give to you last night. I hope it's helpful to you, and I invite you to communicate with me at will. As always, I want to support you. Thank you for your understanding.